Hello guys, so I think I am live now. Wait, I will test my studio and then we will continue it. So basically, we have to learn. Today is the day 3 and we will learn. Okay, so I am live now. It's working fine. So today is the day 3 and today we are learning naive Bayes algorithm. Basically, how naive Bayes work and what is the use of naive Bayes algorithm. Basically, so we have covered linear regression, logistic regression is covered. Now we are covering the naive Bayes, and in the next lecture we will cover a decision tree algorithm. Okay, so let's continue our discussion on the naive Bayes algorithm. So what the name of naive Bayes? Naive Bayes. Basically, naive Bayes work well when your data have independent means independent variable with no correlation. If your data have no correlation, or we can say the independent features like independent variable, then your model will be perfect well. So independent event basically are there. We can see that suppose you have rolled a dice. Basically, this model assumes that your independent variable basically have a independent event, basically no correlation between any of the feature. Suppose you throw a dice and in next time again you throw a dice, then there may be no correlation. Basically, the second throw of a dice will not depend on the first throw of a dice. That means a dependency. So in nib bias, basically we assume that basically your independent feature will have a independency, means they are not dependent on each other basically. So basically naive Bayes works on probability and Bayes theorem. I think you have learned the Bayes theorem in your 12th standard basically. So the naive Bayes formula looks like probability of something like the formula is probability of A given B is equal to probability of A into probability of A into B upon divided by probability of B. So if you see this formula, probability of by divided by W, you can get probability of by into probability of W into y upon probability of W. But you can't able to see like probability of y. Why? I will let you know like why this is not coming. This is the formula probability of and like I have already said, this Bayes theorem, the name Bayes theorem, by name Bayes. Bias means this is not biased to anyone. So that's why the formula is when the name somebody says name bias, by coming to the name bias name, the next thing in your mind will come like it is independent to each other, like they are not dependent to anyone. So this by coming to name bias, you can say probability of A and B equal to probability of B and A. This will be equal because these are independent variables. So probability of A and B, we can write probability of A into probability of B by A. And also there is some factor like probability of B is also there, but in this formula is also coming, so you can neglect it. I will tell you later like why. This is the correct formula, like probability of B by A equal to probability of B into probability of B by A upon probability of A. So you can put it like this also. So this probability of by upon, like by means suppose you are doing a classification problem using a naive Bayes. So probability of yes giving x1 x2 x2 all features, This will be equal to probability of yes into probability of x1 x2 x3 upon yes giving yes upon probability of x1 x2 x3 x2 xn. And also you can write it in another way, like probability of s into probability of x1 up given s, x2 given s, x3 given s, and dot dot dot, something like that. So probability of s given x1 x2 to xn equal to probability of s into probability of x1 given s, x2 given x. This is the formula. And now we will solve the problem. Like suppose you have a problem which have outlook, temperature, humidity, wind, and according to this we have to predicted the like monsoon is able, the player is able to play or not. If the outlook is sunny, temperature is hot, humidity is high, wind is big, then the play time is no. According to this, if the overcast, hot, high, big, then the play will be play, something like that. So according to outlook, you have created a NIP formula. You have to find the probability of this, like if outlook is sunny, overcast, and rain is there. So sunny, overcast, rain, how many times sunny is coming? 2, 4, 3. Like yes is coming, like yes is there, like how many times yes is coming and sunny is coming? Sunny, yes. So you have to calculate this one, and how many times no is coming, something like that. So probability of yes, basically probability of sunny giving yes. So you can calculate this by using a Nib-Bayes formula. So you will get a 2 by 9 probability of sunny giving yes, given yes. How many times is yes? 9. And you will calculate this one. And for temperature, you can also calculate all of these formulas. And now you have to test, like if the sunny is there, like outlook is sunny and temperature is hot, then player will be play or not. You have to calculate this one. So then yes or no also you calculate. So you have to calculate the probability of yes given sunny and hot. So apply this formula: probability of yes into probability of sunny given yes, hot given yes, upon probability of sunny into yes. So this, the division constant, division basically divide, you can say denominator is a constant term. This will also come in this one, and if you calculate the no probability, then it also coming. So we have to not to calculate this probability of sunny into probability of hot, because this is coming in both of these denominator. So what is the use of? That's why we have to neglect this one. Only we have to calculate the probability of S. Probability of S we have already know 9 by 14. And probability of sunny given S. By here you can know sunny given S 2 by 9. Put it all this value and you will get a 0.31. And now again you have to calculate the probability of no given sunny and hot. So you have to calculate and you will get a probability like 0.085. And here you will get a 0.031. So now according to this condition, the player will play or not. So which probability is high? So basically you will get this value, but to we have to normalize this value to find out the correct one. So if you divide this yes by total values, you will get 0.27, basically 27%, and no probability is 73%. So now 7, which is higher, 73%. So that's it, the player will not go to play the tennis. So that's is the easy calculation, we can say. So nib bias is very easy. You can only apply a formula of nib bias basically. That's just remember this formula only, like this is the constant time, so you can neglect it, like probability of yes given all of this feature which was given to you, probability of no given this feature, and probability to find this probability of yes into probability of x1 given yes, x2 given yes, and something like that. You have to calculate this one and you will get a answer. So that's it for this lecture in nib bias. I think I have explained in a good way. Nib bias is very easy. Now the for some confusion or will came like it is now we will uh, solve some interview question like feature scaling is required in this or not. So basically no, because here we are not calculating the distance, basically we are calculating the probability of every outcome. So feature scaling is not required. And the second question, it is impacted by outlier. No. Why? No. Because suppose if in your data set there is an outlier. So basically outlier is also impacted by distance, but here we are not calculating any distance. Basically we are calculating the probability. So suppose in your data set have a outlier. Okay, I think it is impacted by outlier because the probability will get changed according to this outlier. Yes, so it is impacted by outlier. And so person is not going to play tennis. So that's it for today. Nib bias is done. Let's meet in the second lecture. Thank you guys. Hit subscribe button to motivate me, and if you like this content, please share to your friends also if you want to say. Thank you guys.